In this experiment, we're going to be using copper acetate to prepare a solution. It's an aqueous solution, which means that in your solution, you're going to have your copper acetate as the solute, which is what is going to be dissolved. And then, since it's an aqueous solution, the solvent that we're using to dissolve the copper acetate, it's water. So when copper acetate is in solution, what you have is the ion of copper, copper plus 2, and the ion of acetate. But everything that we're going to be recording, all of your experimental data corresponds to the ion of copper in solution. Molarity, it's a unit for concentration. In the same way that we have units for length, mass, weight, we have also units for concentration. Molarity, which we use capital letter M, and it's also known as molar concentration, it's given by the moles of the solute, which is what we're dissolving, and in this case is the moles of the copper ion, divided by the liters of solution, which is the total volume of your solution, but in liters. So, as a summary of the procedure, what we're going to be doing is preparing several solutions with a known concentration of your copper plus 2 ion, which means that we can actually know the concentration of those solutions, and it's the molar concentration. So we're going to prepare a stock solution, and from that stock solution we're going to be preparing the solutions that I have here listed in your number 1. Then we're going to measure the absorbance of your solutions. So the absorbance is just like how much light the solute is absorbing. So we're going to have a cuvette, and in that cuvette we're going to have the copper solution. The orange lines are representing the light that is coming through. And you see how I have 3 lines, and then after the cuvette containing the copper, my blue dots, I have only 1. From the light that is coming into the cuvette, some of that light is going to be absorbed by the copper that you have in solution. So that's what you're actually measuring, how much of that light is actually absorbed by the copper. The more copper ions you have in solution, the higher the absorbance, because if each ion is absorbing some of the light, the more ions you have, the more absorption you will get. So concentration and absorbance, they are directly proportional. As the concentration is increasing, so does the absorbance. And number 3, and I should have a number 4, but number 3, we're going to prepare a graph. And in that graph, you're going to have the absorbance on the y-axis, and then in the x-axis, you're going to have the concentrations for your different solutions that we're preparing in number 1. And then like number 4 is measuring the absorbance for an unknown solution of copper plus 2, and using the graph to find out the concentration of that unknown. So I have that in number 3. Determine the concentration of a copper plus 2 in a solution with unknown concentration. But before you can do that, you need to measure the absorbance for that unknown solution. As part of your procedure, the first thing that you have to do is to find out how much copper acetate you need in order to prepare 25 milliliters of a solution that has a concentration equal to 0.1, and that's molar concentration. So molarity, you have the moles of your solute, which is your copper plus 2, divided by the total volume in liters. So we're preparing the stock solution. So you have a volume because you know that you need to prepare 25 milliliters. That volume in liters is 0.025. So out of the three things that you have in your equation for molarity, moles, and liters. Out of the three, you have two of those three numbers. You have a volume that is converted to liters, and you have a concentration. So if you have volume right here, 0.025, and you have molarity right here, 0.1, it means that you can calculate how many moles of copper acetate or how many moles of your copper ion you need in order to prepare a solution that is 0.1 molar and that has a total volume of 25 milliliters. So molarity times your volume in liters, that's going to give you the number of moles. And you know that to convert moles to grams, you use the molar mass. So the number of moles that you're calculating times the molar mass of copper acetate, that's going to tell you how many grams you need. So remember, the grams that you're calculating is the number of grams of copper acetate that you need to dissolve in 25 milliliters to get a molar concentration that is equal to 0.1. So for you to have your 25 milliliters, that total volume, we're using a volumetric flask. So the volumetric flask, they're calibrated. They measure a specific volume. We have 5, 10, 25, which is the one that we're using. We have 50, 100. So you need to transfer the amount of copper acetate that you're calculating when you're multiplying your molarity times your 0.025 liters. That gives you the moles times the molar mass of copper acetate. That gives you the grams. So those grams of your copper acetate you need to transfer into your volumetric flask. And we're going to dilute or dissolve those grams of copper acetate to the volume of your volumetric flask, which is 25 milliliters. So I will show you in class how to do that part. Now that stock solution we're going to use to prepare dilutions, okay? So we have the stock solution and we know actually the concentration. Look, you know the mass of copper acetate that you need to use and you're going to weigh that amount. So you have the amount of copper acetate that you're using. Then you're dissolving that amount in your 25 milliliters. So you can convert your grams to moles. You have your volume that you can use to calculate molarity. So the stock solution, we know the concentration. So we're going to use that stock solution to prepare dilutions. It means that we're taking a specific volume from the stock and we're diluting that volume to a new volume. So I have my stock solution and I'm preparing 4 standards. All of my standards, all of them, are going to have a total volume of 10 milliliters because you're going to be using volumetric flask of 10 milliliters each one. So that's the total volume. It's determined by the total volume that you have in the volumetric flask. So from the stock solution, the first standard that I'm preparing, I'm taking 2 milliliters from the stock solution. And all of these volumes here we're measuring using a pipette. So 2 milliliters from the stock solution and we're transferring that into the 10 milliliters volumetric flask. Then we have the second one, 4 milliliters from the stock, transfer that into your volumetric flask. For the third one, we're measuring 6 milliliters from the stock and we're transferring that into a volumetric flask. And then the last one, we have the fourth volumetric flask, and to that one we're adding 8 milliliters of the stock solution. So these are dilutions. If you only have 2 milliliters of your stock, those 2 milliliters are going to have the same concentration as the stock solution. But you actually have to dilute those two to 10. You need to complete the volume in your volumetric flask all the way to the line with distilled water. Now you're diluting 2 milliliters to 10 milliliters, and you're going to have a new concentration. The second one, you're doing the same, and you're doing the same for all of them, right? You're diluting from your initial volume of 4 to 10 milliliters, which is the total volume of your volumetric flask. And do the same for the third one and the fourth one. So we have 4 dilutions. The next thing that you have to do is determine the absorbance of your 4 dilutions. But before you can determine the absorbance, you need to actually calibrate the spectrophotometer. So to calibrate the spectrophotometer, you're going to follow the steps that you have in page 117 through 119. And then I'm going to be walking around to check that everything is working properly. And I will show you how you need to transfer your solutions from the standards into the cuvette that you're using to measure the absorbance. Once you have the values of the absorbance for your standards, you're copying your numbers in your lab report. So your experimental data first is the grams that you're weighing of the copper acetate to prepare your stock solution. That's the number one data point that you're collecting. You have to copy exactly the amount that you're weighing. You're calculating an amount, but when you go to the mass balance, you might have something close to that number, not exactly that number. So you need to copy exactly how much you're using. So that's your first experimental point for this lab. And then the volumes, you have them. Your experimental data is the absorbance for your 4 standard solutions. So you have your grams of copper acetate, that's how much you're using to prepare your stock, and then the absorbance for your 4 standards.